She was light and like a fairy, and it looks like we are live. I'll stop singing, get to working. Okay, now we're doing lab 10. Damn it, if it was lab 9, that would have rhymed. All right. So this week is all about titrations. We have in the past done a lab pretty much exactly like this one in person, so it wouldn't surprise me at all if they then went on and asked you to do this in the in-person labs. So titration, you should have already covered it in class, perhaps. You use a solution that you know very, very well. If you look on the screen here, you can see 0.05241 molar hydrochloric acid. So you have a very well-characterized solution, something you know very, very well, to find out information about a solution you don't know nearly as much about. So you are going to do 2 sets of titrations in this video lab thing. You're going to use a really well-known solution of hydrochloric acid in order to measure the concentration of a solution of sodium hydroxide. Then you will use that solution of sodium hydroxide to measure the concentration of a solution of vinegar. That seems complicated, but the fact is that hydrochloric acid is very shelf stable, sodium hydroxide a little bit less so. Also, they want to give you experience making solutions and getting accustomed to how they work. And, just a little bit more practice with titration by having you do 2 titrations in a single lab rather than just the 1 titration. So the way it'll work, let me bring up my papers. So the way titration works is, you'll have your chemical reaction that you're looking at. All right. So sodium hydroxide plus hydrochloric acid makes sodium chloride and water. Straightforward acid-base reaction. You'll have a definite volume, something you know very, very well, for both of your things. But the way it'll work is you'll say, all right, I don't know how much they'll ask you to do here, but say just exactly 15 mils of your sodium hydroxide. That'll be the amount that's sitting, say, in the beaker underneath your burette. You will then pour a certain amount of your hydrochloric acid into your sodium hydroxide. That's what the burette is for. It tells you how much of the hydrochloric acid. It'll give you a nice, very, very precise reading. Remember, you estimate between the lines. So let's say in this case, 12.273 milliliters of your hydrochloric acid. Because your hydrochloric acid is very, very well characterized, you know the concentration of your HCl to, lots of decimal places. This will let you find the concentration of your sodium hydroxide, so 0.05241 molar. So titration is just an exercise in applied stoichiometry. You know the moles of your hydrochloric acid. That lets you find the moles of your sodium hydroxide, and then you can from there get the concentration of your sodium hydroxide. Be aware that the 15 mils and the 12.273, I just made those up. I haven't watched any of these videos. So your stoic reaction, or your stoic math, would be, well, we have 0.05241 moles of HCl per liter of HCl. And we used 12.273 mils. Well, I hope you'll forgive me. Well, let's just go ahead and do it. There are 1 liter in 1,000 milliliters, so 12.273. You're just moving the decimal place 3 to the left. 0.12273 liters. Again, I'm stressing I made up these volumes. 0.012273 liters. Bring up my handy dandy calculator. And come on. There we go. 0.012273 times 0.05241 gets us a very small number of moles. Not particularly surprising. Small volume, low concentration, 0 well, let's just go 6.43, we have 4 sig figs, 2 times 10 to the negative 4th moles of HCl. So, we then use our balanced reaction to do the stoichiometry step. Okay, 6.432 times 10 to the negative 4th moles of HCl times 1 mole, because we're just taking the coefficients, in an NaOH per 1 mole of HCl. Not all of our reactions are going to be one-to-one, but for acids and bases, they very often are. You frequently get a one-to-one reaction, and that's kind of how you want it for an acid and a base. If you have a polyprotic acid, then things can get dicey because the multiple protons, they get weaker, and then you get a complicated equilibrium situation. But for this, you have a strong acid, a strong base. It's going to be very straightforward. But in any event, that means 6.432. Oh, the point was that it's not always going to be one-to-one, so be careful. Make sure you know what acids and bases you're dealing with. Times 10 to the negative 4th moles of NaOH. And now we know how many moles of NaOH we had, so we just take the 6.432 times 10 to the negative 4th moles of sodium hydroxide. We divide that by the volume of sodium hydroxide, 15 mils, or 0.015000 liters. And we come back over here, so now we divide by 0.015. And that gives us the concentration of our sodium hydroxide, 4288 molar NaOH. And then you would go on and do pretty much the exact same thing for the reaction between sodium hydroxide and vinegar, except you're going to have a very slightly, only very tiny difference. Namely, you're going to have a different reaction. It'll look pretty similar, though. NaOH plus HC2H3O2 goes to NaC2H3O2 sodium acetate plus H2O. It's another acid-base neutralization reaction, but with acetic acid instead of hydrochloric acid. And then, in this case, instead of knowing your acid very well, you now know your base very well. Using the numbers I made up, you now have, some volume of your sodium hydroxide, which is 0.0 in this case, in my made-up numbers, 4288 molar, against some specific volume, say, again, 15 mils. I don't know how much they'll ask you for. They would probably just be like 5 mils, because, you want to use smaller quantities. And you would just do the exact same thing all over again. You now have your very well characterized sodium hydroxide that you can use to find the concentration of your acetic acid. So that is one of the simpler things you can use titration for. You can use it also to find chemical activity. You can find the strengths of acids and bases. You can find all sorts of stuff once you get a little bit more theory under your belt. So that's what they're going to ask you to do in this online lab. And then, very likely, they'll ask you to do that in an in-person lab later on. So, part A, or you're going to, let's see, is that where part A? I saw part B, I didn't see part A. Okay, part A, you're standardizing the, sodium hydroxide using the numbers they give you, like I said. And then you're going to then use the sodium hydroxide to standardize, or analyze, I suppose I should say, the vinegar. All right, so that is Lab 10. Hopefully you won't have too much trouble with it. It is a fairly straightforward lab. You're just going to do 2 titrations. One titration of of sodium hydroxide against hydrochloric acid, and the other one of vinegar against sodium hydroxide. So I hope you have a decent time with it. I hope it doesn't give you too much trouble. And with that, I will see you around.